So in the last video, we were showing that these facts that we've been working with, proving a function's increasing, decreasing, or constant over an interval, that these three things really stem and come from the mean value theorem. And in this video, I want to show you a new type of problem that you maybe haven't seen before. And it's comparing two functions, and we're going to do a proof to accomplish this. So we're going to try to prove that e to the x is greater than 1 plus x for x greater than 0. And we're going to try to leverage one of these facts in order to do so. So I know this is probably a new type of problem, but always it's a good idea. Pause the video and try to grapple with this and figure something out and try this on your own. All right. Assuming that you've given it a go. Again, this is a new type of problem, and I'm going to show you just one method to go about doing this proof here. And we're going to start this off by saying start. We're going to start this guy off. So we're going to say start. And our first step is actually going to be defining a new function. And this new function is going to have all of the information in this inequality. So it's going to have both of these functions in there. And what I'm going to say is that g of x is equal to e to the x, and then I'm going to subtract over 1 plus x. So it's going to be minus 1 plus x, 1 plus x. And again, we are still only interested in for x greater than 0. Now, this function here, one thing to note, it is continuous and differentiable for our interval, so that's good, and we can then, because eventually we want to use one of these facts here, so we had to establish that first. But how are we going to prove this inequality if we define this function? Well, what we're actually going to do is get a base point, and we're going to have our base point actually be g of 0. So again, I thought we were looking for x values greater than 0. Well, we're going to look at 0, and then what we're going to do is look at the derivative. And why we're looking at the derivative is so that we can use one of these facts over here. So we'll grab g of 0, look at the derivative, and particularly look at the sign of the derivative. So is it positive, negative, is it 0? And then we'll be able to leverage one of these facts here and make a comparison between g of x and g of 0, because the sign of our derivative will tell us how g of x is behaving on our interval. So g of 0, let's start with that. That is going to be e to the 0 minus 1 plus 0, and this just comes out to 1 minus 1, and that is 0. And then I said we're going to look at the derivative. So we're going to take the derivative of g. And we find that to be e to the x minus the derivative of negative 1 is 0. And then we have minus x, and the derivative of that is negative 1. So this is minus 1. And now, again, we're looking at for x greater than 0. When x is greater than 0, is our derivative positive, negative, or 0? What is it? Well, when x is 0, our derivative is 0, but as x is greater than 0, e to the x is going to be greater than 1. So our derivative here, g prime of x, is actually positive, And what that means is we can now say, therefore, we're able to compare g of x and g of 0. We're able to say that g of x is greater than g of 0. And again, for x greater than 0. And why is that? That's this fact right here. We found that our derivative is positive. Therefore, our function g of x is increasing on this interval. So, and we are continuous and differentiable. So if we started at g of 0, which we found to be 0, and our derivative is positive, well, that means g of x for x values greater than 0 is going to be increasing. That is going to be greater than g of 0. So that is, again, just a fact from what we talked about in the last video. So that is really the crucial part of this proof. And then all we need to do then is back substitute in these values. So we defined g of x as e to the x minus 1 plus x, and then this is greater than g of 0, which we found to be 0. And now to finish this guy off, all we need to do is add over the quantity 1 plus x, so we get this. E to the x, we have proven to be greater than 1 plus x, for x greater than 0. And we could write this guy at the end, QED, which means this was to be demonstrated, which is what our problem was. So that's our proof. We're done. Again, this is one way to go about proving this. And really, again, what I wanted you to see is that we're using these facts in order to prove this comparison of functions. And you'll get more practice with these types of problems in some upcoming videos. But real quick, before we go, I just graphed these out. And you can see definitely when x is greater than 0, that e to the x is greater than 1 plus x.